Good afternoon, Rich Nast, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise, here for this week's Embedded Executive Podcast. This week, my embedded executive is Alex Kai. He is the CTO and co-founder of Zymbit. How you doing, Alex?
I am doing great. Good afternoon.
Okay, so just to level set us here, to be sure the audience is familiar with Zymbit, 30 seconds or less, what do you guys do?
We help people deploy IoT. We are Raspberry Pi centered, but that's not exclusive. And our goal is to make sure that IoT, as it gets more interesting and widens rather than deeper applications, that people can actually get there. And so we do provide security, we provide hardware, and we basically help them to get their stuff on the platform, keep it on the platform, keep it secure, and keep it running.
Okay, so in a previous conversation, I have heard you use security and Raspberry Pi in the same sentence. And all the background that I have says that those things are mutually exclusive, that if you want your design to be secure, don't use Raspberry Pi. And I think you're going to tell me that that's not true. Is that true that it's not true?
It's true that it's not true, but I have to tell a small story. So it is true that Raspberry Pi started without much of security, but also Zymbit was started to address that issue, and it has been addressing that. But just in general, there's a bit of context here. So Raspberry Pi has a wonderful thing going for it, which is simplicity. And in my view, its simplicity and its openness is what's ultimately going to actually result in a much better long-term security for anything that uses the Pi. That's because there are not hundreds of thousands of lines of code in between everything. There's not a heavy BIOS. There is not a large boot environment and lots of mystery code. So the way I see Pi security is that obviously it has been improving. So Pi now has secure boot, and Pi needs to be paired with a secure element. But because of the simplicity, long-term installations with a Pi, when properly set up, I think they're much more robust, for example, than, I don't know, an x86 installation, right? Installing Intel NUCs versus Pis is an old discussion, is all this time.
Okay, but the beauty of Raspberry Pi is its simplicity, as you said. Are you taking away that great feature of it by making it not so simple anymore, by adding all these layers on top?
Well, the layers have to be right for what's being for the application at hand. So if the goal is long-term stability and maintainability and making sure that things run well, then the layers have to match that. But the layers, nonetheless, they're much more transparent and they can evolve, just as everything evolves. Versus, for example, a lot of baked-in, things they cannot. So yeah, it's making it a little bit less simple, but I think it's still massively simple than anything else that you'd find elsewhere.
Okay. So are you betting your company's production line on a Raspberry Pi that it won't get hacked?
Absolutely. We have Raspberry Pis configuring secure Raspberry Pis and various manufacturing appliances running more Raspberry Pis.
Okay. All right.
Yeah, absolutely. I should say something. So I think that the context is important, and we're talking about IoT devices, right? So this is where, generally speaking, it's not a full desktop experience. So these systems can be kept pretty tight. So then the focus shifts, what else can go wrong? And I think it's in that department, what else can go wrong in 3 years, 5 years down the line? That's where I think Pi pulls ahead. And then also, just to generally say that there's also the whole subject of secure elements, and TPMs were originally set up for desktop use, maybe server use. It doesn't mean that they automatically translate well into IoT applications. So I think that a big portion of this is the security module set up for unattended operation? Does it require a trusted human, et cetera, et cetera? So that's also an interesting subject.
Okay, so can you go down a level and explain how someone would actually implement this?
Right. So, so in case of, let's say, an unattended IoT application, Raspberry Pi, uh, normal, uh, as expected types of setups, what you do is you would take a Raspberry Pi. You would obviously use its built-in security features. You would use the secure boot and so on and so forth that needs to be properly configured, and then you would add on um, a hardware security module. I would suggest that a regular desktop TPM is not really going to do the job, and we can go in depth why that is the case. But just as in general context, it's not set up for this kind of an application. Um, a hardware security module, for example, such as Zymbit's HSM, that is a hardware security module that has been entirely developed by Zymbit specifically for these kinds of applications. So what HSMs do when set up properly, they basically wrap the host. So the host being on an inexpensive, basically a sub $10 CPU, that's what we're talking about here. Sub $10 piece of silicon that, if managed correctly and if given correct security settings, can be actually made quite secure. And even in some ways more secure than an x86 system, because, for example, what we can do is we can isolate different encryption keys for different boots. So A and B can have their own sets, for example. That's kind of hard to do with an x86 secure BIOS, because nobody really contemplated somebody might need to isolate A and B boots, not to mention to have them. So those little details, they really do it up.
You had me right until the if executed properly. So who is the onus on? The designer to execute it properly? And how hard is that to do?
Great question. Fantastic question. So obviously, there's a lot of pressure on IoT engineers because everyone expects them to be an expert in every possible discipline, including security. And truth be told, most of them are pretty competent, but security stacks are an art of their own. So yeah, having a good security stack is super important. That is set up to not leave any particular part of the secure chain unsecured. So it's all about secure chains, and yeah, so
So how
security
is it
stacks that are built ground up for IoT. That's where you want to be. You don't want to be on some homebrew random
right?
combination of bits. That's really bad idea.
But how would the developer even know if it's implemented correctly using the terminology we've been using? Would it be not till after he was hacked and he has a, oh my God moment, I did this wrong?
All right. Yeah, so there are some general guidelines, right? So there has to be a demonstrable secure chain. That's very important. Isolation is very important, for example, when an upgrade is done, so that the software that's upgrading the system cannot somehow have a malware that jumps onto the new install. For example, those kinds of details are important. Physical security is super important. So perimeter detects, proper perimeter protection, again, armed and set up so that it will actually render the system at least unbootable if intruded, or maybe permanently uh, uh, disabled. So yeah, so Zymbit, for example, has various forms of security checklists that we go through. I should also say that it can be a daunting task to go through all that, and that daunting task often gets pushed to the end, where after everything's done. So we do recognize. So pilots are different from scale deployment. They really are. They have different goals. They have different metrics. So if somebody is doing a 50-unit pilot somewhere, they probably don't need to quite go through quite the same process, but they have to make sure that the process can happen in the future. So there's an important distinction. Zymbit, for example, has different hardware that we give or sell to users to use in different stages of their project that happens to have a different level of lockup.
Okay. I'm going to take this for a spin because I would love to be able to operate with a secure Raspberry Pi. And until now, I didn't think I could do that.
Very good.
Thank you very much, Alex. I appreciate you taking a few minutes to educate the audience.
My pleasure. My pleasure.
That was Alex Kai. He is the CTO and co-founder of Zymbit, and I'm Rich Nass with Open Systems Media.